Hello, welcome back. We are now on to the second half of our third problem. And what I've done is sum up what we just did. We got the x and y components of the two forces that our charge 2 is experiencing. And you can see the way I wrote them. Now it is easy to do some vector addition and get F2x and F2y. So F2x, that's some easy math. F2y, adding these two together, they're both pointing in the negative y direction. It's going to be negative 1.92 times 10 to the negative 7th. Okay, then now that I have these, I can go ahead and use the Pythagorean theorem and a little bit of trig and get the overall force and the angle. It's always good to sort of have a reality check and see, like, does our answer seem like it's going to make sense? So just to remind you what our drawing looked like here, here's Q2, there's Q1, there's Q3 that we had, there's our F12, there's our F32. Our answer should fall somewhere in here, right? We should be getting that the total F2 should be, if we add those two vectors together, should fall somewhere in here. All right, so if we look at that, since they both had negative x and negative y components, I'm going to call this F2x. Let's imagine here's our Q2, and I'm going to draw the overall force on its x and y components. F2x points left, F2y, which is larger, points down. So the overall F2 is the hypotenuse there. And then let's call that theta 2. That's the angle we want to find. So then we can get overall F2 using the Pythagorean theorem. And for F2, then we end up getting what comes out to just about 2 times 10 to the negative 7th. And then theta 2, we could do any number of trig functions. I like inverse tangent, right? Inverse tangent y over x. Tangent is opposite over adjacent. We're going to get theta is the inverse tangent of F2y over F2x. And that's going to give us an angle of about 73 degrees below the x-axis, the negative x-axis, right? Because it's over here on the left. Okay, so then this is my final answer, and indeed 73 degrees, yep, that does fall in here. That seems reasonable. Again, I can't answer any questions now like I would in class, but if you have any questions, please go right ahead and email me, or bring them to my office hours once we eventually do get back in class. All right, thanks, stay warm.